You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back to another edition of Product Thursdays here on The Vocal Technologist. I'm really buzzing for this one.
Oh, yeah.
Yeah, because we usually talk about the shiny front-end stuff, the things you can actually see and touch on a screen.
The user interface.
Exactly. But today, we are going into the basement. We're looking at the huge invisible machinery that keeps the digital world from just collapsing.
It's good to be here. And you're right, the basement is where all the action is.
Yeah.
It's so easy to forget that under every smooth app, there are like turbines spinning just to load your profile picture.
Totally. And the theme today feels like a shift. For years, the mantra was big data. Just hoard it all.
Store everything. Sort it out later.
Right. But looking at what we've got on the table today, from Netflix, from Pinterest, it feels like we're moving into a new era. It's not about size. It's about precision.
That's the perfect way to frame it. Big data was a brute force idea. It's a sledgehammer. What we're seeing now is the era of smart data.
The scalp?
The scalpel. Exactly.
Right.
It's not impressive anymore to say, I have a petabyte of data. The real question is, can you move it without breaking everything? Can you understand it instantly?
And can you do it without going broke on cloud costs?
That too.
So we have a packed session ahead. We're going to talk about a migration from Monday.com that honestly sounds like changing a plane engine mid-flight.
It's not far off.
We're going to talk about healing broken data. And later, and this is my favorite bit, we're going to look at a simple file compression tool that can somehow beat complex AI models.
That compression story is just a wonderful reminder that sometimes the simplest tool is the right one. But we should probably start with that Highwire Act.
Let's do it. Monday.com. So if you're listening and you work in tech, the words database migration probably give you a cold sweat.
Oh, yeah. It means downtime. It means 2.00 a.m. phone calls.
It means apologizing to customers. But Monday.com just moved their huge Cassandra clusters, this is their core production database, to modern systems. And they did it with zero downtime.
And zero data loss.
How on earth do you even do that? It's like changing the engine on a 747.
While it's flying over the Atlantic.
And you can't let any of the passengers spill their coffee.
Well, the trick is, with distributed databases, you can actually be in two places at once. That's kind of the point of them.
Okay.
So they leverage Cassandra's own architecture. Instead of a lift and shift, they spun up new data centers in the new environment and just introduced them to the old ones.
So they basically said, hey, old servers, meet the new servers. You guys are on the same team now.
Pretty much. And they use something called gossip protocols to do it.
I love that term, gossip protocols. It sounds so human.
It is. It's a way for all the computers in a network to share what they know. I'm alive. I have this piece of data. They just let the old servers gossip all the data over to the new ones.
But just syncing isn't enough, right? With that much data, things must get lost or corrupted.
Right, and that's where the orchestration came in. They used a tool called Temporal. It's an automated workflow engine. So it wasn't just a script they hoped would work.
It was like an air traffic controller.
Precisely. It managed the streaming, and it repaired any data that got mixed up, all in real time. Then they just slowly turned a dial. They gradually rerouted traffic to the new system.
So clever. It's surgical. And speaking of clever, let's talk about Pinterest. Because they were trying to fix a different problem. They were trying to fix time.
Right. Time is everything in their business. Pinterest was stuck in what we call the batch era.
Sounds prehistoric.
In tech years, it is. Batch processing is like getting your news from the morning paper. If something trends at 10 a.m., you won't see it until the next day.
And by then it's over. You've lost.
You've lost. So they needed to go real time. They moved to a streaming system using CDC change data capture.
Okay, so break that down. What's the fundamental shift?
So instead of asking the database for a full copy of everything every night, you just you listen to its diary. You capture every single event as it happens.
So it's the difference between a photograph and a live video feed.
Perfect analogy. And they built a system to stream all those changes using Kafka, and then they dumped them into something called iceberg tables.
Iceberg is everywhere now. Why is that so important here?
Because streaming can create a huge mess of tiny little files, which kills performance. Iceberg can bring structure. It has this trick called merge on read.
Meaning you don't have to rewrite the whole file every time one tiny thing changes.
You got it. It just makes a note of the change and sorts it out when you actually need to read the data.
So what was the payoff? Why go through all that?
Two things. First, speed. They cut their data latency from hours down to just 15 minutes. But here's the kicker.
Go on.
They cut their compute costs by 40%.
40%. That's massive.
It is. If you're only processing the small slice of data that actually changed, instead of the whole petabyte every single night, you save a fortune.
That is the very definition of smart data. But, okay, sometimes smart isn't enough. Sometimes you just need raw, terrifying power.
And that brings us to Meta.
Yes. Their new AI training cluster, Prometheus. The numbers here are just staggering.
They really are.
They're talking about a cluster with a 1 gigawatt capacity.
1 gigawatt.
That's a nuclear power plant? That's enough to power a whole city.
Roughly a city the size of San Diego, just for one computer.
Why? I mean, why do you need that much power?
Well, it's the chips, sure, tens of thousands of them. But the real story with Prometheus isn't just the compute, it's the networking. The wires between the chips.
The bottleneck.
Always. When you're training a huge model, those thousands of chips have to talk to each other constantly. If the connection is slow, the chips just sit there, idling, burning power.
So how'd they solve it?
They build a custom network. The stat that blew my mind was the bandwidth. They're achieving petabit-level bandwidth.
A petabit? That's 1,000,000 gigabits per second.
Yep. It just grounds you, you know? AI isn't some weightless thing in the cloud. At this scale, it's a massive industrial project. It's copper and fiber and city-scale power grids.
It is. But, okay, we have all these giant super-fast pipes. But there's danger there, right?
Wait,
If you pour poison into a high-speed pipe, you just poison everyone faster.
Ah, yes. Garbage in, garbage out. At hyperspeed.
Exactly. Which is where Netflix comes in. They built something they call the data canary.
And it is exactly what it sounds like. It's a nod to the old coal miners.
They'd bring a canary down into the mine, and if it stopped singing...
You knew there was toxic gas, and you got out of there. Netflix does the same thing with their metadata.
So, show descriptions, episode lists, that kind of thing.
Right. Imagine a bad update goes out, and suddenly Stranger Things is labeled a cooking show. It breaks the whole experience.
So how does the canary work?
They run a canary cluster in parallel with their main production cluster. They feed it live traffic, real user requests, and they compare the results.
A taste test.
A taste test. And if the canary's results start to look weird or return errors,
the bird dies.
Metaphorically, yes. The system automatically blocks the deployment. They can stop bad data in its tracks in under 10 minutes.
I love this because it treats data with the same seriousness as code. Usually data is kind of an afterthought.
That attitude is disappearing. It has to. Now, staying on this idea of fixing things, we have to talk about healing tables.
The name is fantastic. Sounds like a spa day for your database.
It kind of is. It solves this really common problem, the slow-motion disaster.
Oh, I think I know what this is. This is when you find a bug from 3 years ago.
Exactly. Most warehouses just add new data on top of old data. So if you find a bad calculation from 2021, every single day since then has been built on that faulty foundation.
And fixing it is a nightmare.
A total nightmare. Healing tables takes a different approach. Instead of just adding new bricks, it uses deterministic, fully reproducible builds.
Deterministic. That's the key.
Yes. It means you get the same output every time. They use time slicing, so you can basically reload your data from a specific point in time, say, before the bug applied the fix, and rebuild history correctly from that point on.
It's like having save points in a video game. That's a game changer. But that's for logical errors. What about just messy human data?
Right. Typos, weird formatting. For that, we're seeing this rise of AI-augmented quality.
So we're finally moving past writing 1,000 if-then rules.
We are. The old rule-based approach is just too brittle. Now we have deep learning models with names like Sherlock and Sato that can do semantic inference.
Meaning they understand the meaning of the data.
Correct. They can look at a messy column and say, despite the chaos, this is a phone number column. And the research shows they're up to 14% more accurate in noisy situations.
So we're using AI to clean up the data we use to train other AI.
The snake is eating its own tail, and it's delicious.
This actually leads to a really interesting cultural point, this idea of fast fashion code. As a developer, that sounds like an insult, like cheap, disposable code.
But if you're building a banking app, it is. But the argument here is that for data exploration, it's actually a superpower.
How so?
Because if you're just trying to get an answer out of a messy PDF, you don't want to spend 6 months building a perfect, robust application.
You just want to write a quick script, get the insight, and throw the script away.
Exactly. The goal is the answer, not the elegant code. But, and this is a huge but, that's for humans. When we start feeding this data to AI agents, we can't be that sloppy.
No, and that's the paradox, and it's leading to this new role, the context engineer.
This is a huge shift. Data teams are becoming context teams.
What does that mean? What does a context engineer do?
Well, if you connect an AI directly to your raw company database, it's going to go off the rails.
It'll start hallucinating or treat some test table as the absolute truth.
Right. It has no context. The context engineer's job is to build a governed, curated layer between the raw data and the AI. They decide what reality the AI gets to see.
They're like the AI's librarian.
Exactly. And your success isn't uptime anymore, it's answer rate. How often did the AI give the right answer based on the context you provided?
And to build that context, we're seeing this move towards something called GraphRAG.
This is the next step. RAG retrieval augmented generation is good, but it's fuzzy. It finds similar documents.
And GraphRAG adds structure.
It combines the fuzzy vector search with a knowledge graph, which has explicit relationships. This person works for this company.
So the AI knows how things are connected. It's not just guessing.
It enables recursive reasoning. It's a step toward giving the AI a kind of episodic memory.
Okay, speaking of AI and clever tricks, we promised one. And I have to say, when I read this, I thought it was a joke.
The text classification with a compression tool.
Yes. How does using a file compression tool tell you if a document is about sports or politics?
It sounds absurd, but it's based on really fundamental information theory. This involves a tool called Zstd.
Which just makes files smaller.
Right, and it does that by finding patterns and creating a dictionary. So imagine you build a dictionary from 1,000 sports articles. It's going to be full of words like touchdown and score.
Got it.
Now, you take a new, unknown article, you try to compress it using that sports dictionary.
If it compresses really well, if it gets tiny, it means it's full of sports words.
Bingo. It found the patterns, you try to compress a cooking recipe with it, and it barely shrinks at all.
That is just so brilliantly simple, and the results are good.
The results are shocking. On a standard benchmark, it gets about 91% accuracy.
91%. That's as good as some complex machine learning models.
And it does it in under 2 seconds. No GPU required.
It just shows how we can over-engineer things sometimes.
Simplicity wins. And that kind of brings us to our last big topic, architecture. For years, the cloud mantra was store everything.
Storage is cheap, right?
Well, that model is breaking. The research shows that something like 70% of observability, data logs, metrics is just waste. It's just noise.
And you're paying to store and search all that noise.
Exactly. So the shift now is toward AI edge proxies.
Filtering at the source.
Right. Put a tiny neural network on the server itself. Let it look at the data stream and decide what's important enough to send to the cloud. That's normal. Ignore it. Wait, that's an anomaly. Send that.
You only store the interesting bits, and that can cut storage costs by
40 to 60%.
Wow. But, okay, even for the data we do keep, there was a pretty spicy take in the research about data warehouses. Someone called them expensive museums.
I love that quote. The argument is that most data warehouse failures aren't technical. They're semantic.
Meaning we can't agree on what the words mean.
Yes. If the marketing team's definition of customer is different from the sales team's definition, it doesn't matter how fast your database is. The reports will be useless.
And you get this expensive, perfectly built system that nobody trusts or uses.
The museum? You can look, but you can't touch.
So what's the alternative?
We're seeing a rise in query federation. The idea is don't move the data, leave it where it is, in different databases, in storage buckets, and use a tool like StarRocks to query across all of it in place.
But isn't that usually really slow?
It used to be. But these new engines use something called vectorized execution. Instead of processing one row at a time, they process whole blocks of data at once.
Ah, so it's processing in bulk.
And it's incredibly fast.
Yeah.
It makes these federated queries almost as fast as a central warehouse, but without all the work of moving the data.
We've really come full circle then. We started with Monday.com moving everything, and we're ending with the idea that maybe you don't have to move anything.
That is the pendulum of technology. Centralize, decentralize, store it all, filter it all.
Keeps us busy, I suppose. So let's try and wrap this up. We've gone from open heart surgery on a database
to using data canaries at Netflix to protect us from bad metadata.
We learned that a simple compression tool can be a surprisingly good text classifier.
And that the store everything mantra is dying. But I think the biggest theme here is the change in the human role. The context engineer.
I agree. That feels like the most important shift. The data team isn't just building charts for humans anymore. They're building reality for the AI.
They are.
Hmm.
Which leads to a final kind of provocative thought to leave everyone with.
Let's hear it.
Well, if the data team is curating the context for the AI, if they're deciding what it sees and what it ignores, are we moving from an era of objective data truth to an era of curated perspective?
That's heavy, because whoever designs that context layer is effectively controlling what the AI believes to be true.
Exactly. You're not just building a data pipeline. You are building a worldview for a digital mind.
And that is a huge responsibility.
No pressure.
No pressure at all. Wow. Okay, on that note, we are going to wrap up. I'm going to go see if I can compress this entire conversation down to a single file.
I think it would classify as educational thriller.
I like that. Thanks for tuning in to The Vocal Technologist. Keep building, keep learning, and we will catch you on the next one. Goodbye.
Spoken Tech for your ears.